Hello everyone and welcome to our today's webinar on neural style transfer and deep tree. I am Dhanashree Meshram. Today we are going to understand about two groundbreaking techniques, which is here we will understand a clear picture how they fit into a production site and how these techniques work in the backend. Why these techniques matters a lot. So we'll understand about first neural style transfer and the deep tree. These are the two techniques we are going to understand. And we will going to understand the codes also. So here, why this technique matters? So these techniques are useful for artistic expressions at scale. Like a neural style transfer empowers anyone to reimagine a photograph in a style of masters. Like we can use a Picasso or some other library, all by harnessing a pre-trained convolution networks. And it can also be useful for model interpretability and insights. The real world applications for here is we can use it for marketing, game design, immersive media, and even for anomaly detections. So our architecture overview, when we will see the architecture over here. So in our architecture, we can have a multiple input sources. We can have a multiple input sources. So if we want to overview this, all the things, all this architecture diagram, so there are total 5 different zones over here. First is our input sources, wherein our static images or real-time video streams will be there. Then after, wherein you can use your uploads option and you can curate your style and the content data set, both the things. Okay. Then after that, we are having a ingestion and pre-processing set or ingestion and pre-processing zone, wherein we will have a unified data collector funnels inputs into a pre-processing engines that will handle resizing, normalization, frame extractions, and it will also do a format conversion. After that, we are having a model processing. Here in the model processing stage, there are two parallel pipeline going on. Okay. One is for the neural style transfer and second is for the deep tree. So each leveraging a GPU or a TPU resources, which is orchestrated by a model management layer. After this, our fourth zone is an API layer and monitoring. Okay. So here, the RESTful interference API that will serve a stylation and dreaming endpoints. It will complete with logging, latency, tracking, and resources monitoring. So all the things it will be collectively handling. Then at the end, we are having our output or a storage. Okay, so how this output and storage is working means after all this finalized images and the videos are selected, plus the model artifact is generated, what we will do? All the versions are stored in a object storage with a configurable retention policies. So here, if we want to talk about what will happen in data ingestions, we will imagine a user who is dragging a selfie into the web app or feeding a live webcam streams into a batch job. The data collector injects every request and handles it off to the processing engine here, wherein what will happen, it can be useful for resizing the images, it can be useful for normalization of the images, then it can be useful for frame extractions. All of these will be happening in data ingestion and pre-processing. After this, the neural style transfer, which is a concept here we are having a content representations. So wherein we can use our pre-trained models like VGG16 or VGG19. These maps will encode a spatial layout and have a high level shapes of the content image. Then we will have a style representation. So within the style representation, we'll compute the gram matrix, which will have a multiple convolution layers. These will capture the correlation between the feature classes or the feature channel between them. Okay, and it will have a brush stroke textures and color palettes as well. Also here we will have our loss computations. Once the model is ready, once the model is done, we will have a loss formulation also. So within this loss formulation, we are having content loss, child loss, total variation loss. So there are multiple types of losses. So after we will select all this data model processing steps, we will form our API layer and the monitoring and logging layer. Once both are finalized, we will see for the generated image or the output and storage section, wherein all the generated images will be stored over here, or generated videos will be stored over here. Okay, so this is what it is happening. So there are two types of thing over here. There are two models. First is a neural transfer and second is a deep dream. So we'll see inside how it is working, how actually inside it is working. So here in the neural network, in this deep dream, or before going for deep dream, we are having our this one, neural transfer. Within this neural transfer, we are having, in our architecture, we are having a pre-computed feature maps. Pre-computed feature maps for a selected content and the style image. So we are putting a content image and the style image. What style we want. Okay. Or what content, for what content we want what style. So we are putting these two images. It then dispatches an optimization job to a GPU cluster. Then after that, we are having a batch versus real-time images. For high volume use, we will typically pre-compute the style statistics and run the transfer offline in a batch of, anyways, like we can have a 50 to 100 images at a time. We can have 100 to 200 images at a time. Likewise, for an interactive demos, we can spin up a TPO pods which can deliver a results in under 10 seconds also. Then we are having a model management. Within a model management, we are having a dedicated registry which will check the checkpoints within this. Having a versions of the style, what is the version of the style, and the optimization hyperparameters, whatever we are using. So we can have an A or B testing. And a weights and iteration counts as well for this particular model, for this particular neural transfer model. Then we can have a live demonstration of this also. Like in the live demonstrations, you can have any image you can put. We will see in our live demonstration as well. So we can put any image and we can put any other what is that? A static image versus your original caption image. So both the images we are putting, and then we are going to see the low weight versus high weight. Low weight means it will retain more of the original colors and shape, and high weight means it will fully embrace the style textures, even at the expense of fine details, fine content details. So there are two things that we are focusing. Once we will complete our coding part, you will have better understanding of this. Then we are having a deep dream. Within the deep dream, there are multiple layers over here. So there is a layer selection first. So here, this deep dream takes almost the inverse approach. Instead of minimizing the losses, we maximize the neurons activation in a chosen layer. What this will do? So this will dream like an imaginary, which will reveal the pattern a network has learned from here. Then we will have our layer selection. Early layer produces the edge enhanced pattern. Deeper layers, which will hallucinate a complex shapes like eyes, animals, or architectures. Then we will have our gradient ascents. Each iteration will compiles the strongest activation over here. Strongest activations combined with the image jitters like tiny random shifts or a multi-scale processing like octave. We will get our coherent features from here. Now, what are the use cases of this deep dream? So, you can use it for security researchers which have used the deep dream to reveal the backdoors in our vision models. Designers use it to generate the concepts like arts and textures. For all these purposes also, we can use this deep dream model. Okay. So when it comes to a production side, we will have our interactive mode, batch mode and caching or a reuse mode. 3 modes will be there in this deep dream. So interactive mode, which is a live webcam feed, can be dramatized, will have 2 to 5 frames per second. If it is a video, if it is a webcam, we can have a 2 to 5 frames per second. Then batch mode. Batch mode is for higher resolution output or a video processing. We can break the inputs into tiles or a dreamify. Likewise, we can use it. Catching and reuse. So by pertaining to intermediate activations for popular layers, we can use it for redundant computations and we can use it for different amplification scales. Now, when it comes to output and storage part, so we will take both the models, we will see the monitoring and logging part, API layers, all these things we will do. And whatever the generated image will be there or generated videos will be there, depending upon that, we will store it. Somewhere we are going to store it. So here there are 2 layers here. First layer is an API layer and monitoring layer. So within this API layer and the monitoring layer, what we are doing? We are having a payloads. Okay. So once the API layer is exposed, 2 primary endpoints will be there. First will be a stylize and second will be a dream. So these key considerations we have to take. Okay. So after this, we can have a monitoring and logging at tracking of 50th or a 90th or a 99th percentile of latencies to ensure the interactive great performance. Okay. Likewise, we can use it for error rates also, for monitoring the error rate, for monitoring the user behaviors. For all these purposes, we can use it. So now what we have understood in the today's part is we have understood about the neural transfer and we have understood about the deep dream. There are the 2 techniques. Neural style transfer is nothing but it will leverage the feature and the gram matrix losses to blend the content style. Content is one thing, content we are giving and the style, there are various types of styles available. From that, we will choose any of the style with the artistic fidelity. Then there is a deep dream, which will amplify the learned features by gradient accent, providing a videos into models, internal and creative hallucinations within the image or within a video. So our production pipeline requires a rewards model pre-processing, data pre-processing, and then the use of GPU and TPU orchestrations is required. Model versioning, scalable APIs, all these things are there. And then of course, there will be a monitoring part. Continuously comprehensive monitoring is required here. Okay. So this is what we have understood from here. So let me quickly. So here we are using our TensorFlow framework. So we are installing our required libraries over here. Here, as you can see, there are 2. First is our content image and second is a style.jpg. So we are using here a Picasso.jpg style. Okay, and this is our image which we are directly taking from our open source platform. Okay, we are directly integrating from open source platform, readily available images in a open source platform. So we are taking that image from there So here the image is dancing.jpg image is there, which is our content image, which we are providing. Along with that, a style.jpg image is there, which is we want a style of Picasso.jpg. So we are importing these two things together first, and then we are having a neural style transfer code. So as you can see here, we haven't imported any videos. We have imported only the image. So here it is easy. If you will import a video, it will take a real time. It will take a time to input all frame by frame. It will take all the frames. And then we can use it for video. We can use it for web camera. Multiple things we can use it. So we are using this particular thing. Then here, as you can see, we are importing our pill library. We are converting them to a tensors by using a PyTorch framework. Here we are having a torch widget. Okay. So we are using this pill library. We are using our VGG16. Oh, sorry, VGG19 here we are using. Not a VGG16. We are using a VGG19 model. A selected layers we are taking as 0, 5, 10, 19 and 28. These are the layers which we are taking, and the model we are choosing is VGG19, which is a pre-trained model. Okay, so we are using a VGG19 CNN model that was trained on an ImageNet. Okay, this model is used not for classification but to extract the features from the images. Okay, so we are using this particular thing. Then we are using the feature extraction. Feature extraction will do what? It will take the model, extract layers, and it will form edges, it will form shapes, textures, likewise it will form. Okay, then we are having a gram here. We are having a gram matrix. In this gram matrix, we are having a matrix used for capturing the style information from the image, like textures or patterns, whatever the textures are there or patterns are there, we are going to extract here by using the gram matrix. Then we are having a style transfer, which is a user-defined functions we are providing. So here in the style transfer function, what we are doing, we are creating a content and the style image. Both the images we are taking. We are creating a copy of the content image and we are gradually changing it to mix with the style. So you can see here the output it is giving. You can see this was the image. This was a dancing image which was a context image, and we are having the Picasso as a style input or a style JPEG which we have. So it is capturing both the things together. You can see here. Okay. Now display will do what? It will take. Now here you can see we are having a display option over here. Okay. So within our display, what will happen? Every 10 steps, the image will be generating. So here you can see this images are nothing but our content image, which will be painted in a Picasso style. Okay, which is painted in a Picasso style. Okay, so this is your original image, which is we are combining this content image with a style icon. Here we have taken a Picasso style. Okay. So after this, we can have a look on Deep Dream also. For a Deep Dream also, we are doing the same thing. Here also, we are using a framework, which is a TensorFlow framework. We are using a load images. We are deprocessing the images and we are having the. So here, we are not getting any steps only we are getting. We are not getting the image over here. But you can see the image over here for your neural style transfer code. Okay. So I hope now after running the code, you will have a better understanding of what we have understood in this architecture diagram. Okay. So this is it guys from my end for today. We will see with the next, we will see on the next topic on next Monday. So thank you for joining guys.